Hi everyone. This is our second video on 5G. Today we're going to discuss uh, the fundamentals of 5G, basically the introduction to the fundamentals. So I'm gonna write down here. So introduction to fundamentals of 5G. So as you all know, right, 5G has been introduced in which release? That was release 15, right? So release 15 and 3GP specifications, right? And your LTE was introduced in release 8 of 3GP specifications, right? Now we are talking about 5G. So 5G has been specified based upon the requirement of some use cases. So basically there are three use cases if we discuss them. So the very first is your eMBB, that is enhanced mobile broadband. So as we know, LTE introduced mobile broadband, right? So that is enhanced in our 5G. Now, second thing is our URLLC. URLLC means ultra reliable and low latency communication. Ultra reliable and low latency communication. And third one is ultra reliable means reliable. There should be some reliability on the data part, right? Data should not be lost. And low latency means there should not be any delay in transferring the data or receiving the data, sending the data, right? Third one is your massive machine type communication, mMTC. Okay. So as we know, radio access network belonging to LTE is known as LT, 4G is known as LT, right? Where RAN belongs to 5G is known as your NR. That is your new radio, right? So NR को standardize किया गया है. Why? To allow the tight internetworking between LTE and NR. Or let's say to allow the tight internetworking with LTE, right? Okay. So now whenever there is a internetworking between LTE and NR, so that structure is known as your NSA, non-standalone, right? So non-standalone architecture, this allows basically a smooth and relatively simple evolution towards a complete end-to-end 5G system, right? Means your LTE, let's say if you take an example, right? So this is your GNB from LTE, and this is your UE here, and this is connected to your 5G. Sorry, this is not GNB. This is your, excuse me, this is our ENB, and this is your 5G GNB, and these both are connected, and then you have this 5G core here, right? So this is an example of NSA, non-standalone, right? So non-standalone, what it does basically, it provides the connectivity from LTE to 5G to 5G core, right? So in general, basically, you can have a software upgrade is sufficient, or you can say software upgrade is required at LTE station basically to support this connectivity with the 5G basically. So if we talk about standalone, right? In case of standalone, so there is no role of LT here. Standalone means only 5G is there. So which means you have this GNB and your 5G core here, and here you have UE, right? That's a simple structure there. So that's a counterpart of LT here basically, right? Now if we move further, right? So NR base station have a flexible architecture, right? So which supports, जो कि support करता है dynamic, you can say a range of deployment, right? So if we take an example of classic base station architecture, right? So a base station, so if we talk about base station, right? So a base station can be split into two parts. Base station. So this base station can be split into two parts. So one is your CU and another one is your DU. So CU means your centralized unit and DU is your distributed unit. Right? Now, a CU, that is centralized unit, that handles basically your high protocol structure, right? And your distributed unit handles your lower protocol layer stack. So a single CU, you can say, basically handles a large number of DUs, maybe greater than 100, you can say, right? And while each DU can host multiple cells, right? Maybe greater than 6, you can say. So now the question comes, right? Why there is a 5G came and why there were two divisions in the frequency, right? So what happened basically, there was some congestion within the lower band, right? Congestion within lower band. Lower band, right? That combined with the requirement for a wider channel bandwidth, right? And which has led to the specification of low and high operating bands for 5G basically. So release 15 has adopted basically use of two frequency ranges. The first one is your FR1 and second one is your FR2, right? So FR1 goes from 450 megahertz to 6 gigahertz. So it is also known as sub 6, where FR2 ranges goes from 24.25 gigahertz to 52.60 gigahertz. So this is basically millimeter waves, right? The higher frequency band. So FR1 range supports the channel. Now, if you talk about the channel bandwidth, right? So this FR1 supports the channel bandwidth from 5 to 100 megahertz, and this FR2 supports the channel bandwidth from 50 to 400 megahertz, right? Now there is a question for you, guys. Can you guys tell me what is the channel band? What was the channel bandwidth in LT in the comment section, please? Okay, so FR1 includes operating bands which supports frequency, like FR1 में कौन से आपके frequency band support करते हैं? So there is FDD supported, there is TDD supported, there are others are also there, like supplementary downlink is there and supplementary uplink is there. This we're gonna go in detail later part, where your FR2 only supports TDD band, right? Okay. So if we talk about 3GBP, right? So 3GBP has specified the mechanisms to allow the dynamic changes for uplink and downlink transmission. वो कैसे होता है? Uplink, downlink to uplink, uplink downlink. That is happens via TDD, right? Time division duplexing. So this was about FR1, FR2, and which technology they are using. Now, if we talk about like which cyclic prefix OFDM they are using, so we're talking about NR, right? So we have two directions here, UL and DL. Okay. So in uplink and downlink, both we use CP-OFDM. CP-OFDM is your cyclic prefix orthogonal frequency division multiplexing. In addition to this, we can also use DFT S OFDM, right? That is your discrete Fourier transform spread orthogonal frequency division multiplexing in the uplink direction to improve the coverage. Right now, both the waveforms, if we talk about CPO FDM and DFT S FDM, तो ये क्या क्या use कर सकते हैं, right? Let me change the color, maybe green, right? Okay. So these both the waveforms can use your UPSK or 16 com, 64 com, 256 com. Now, if you talk about DFT SOFDM, discrete Fourier transform spread orthogonal frequency division multiplexing, this can also use pi by 2 BPSK, right? So, and this is especially in the weak coverage areas, right? So now we have known, right, which multiplexing schemes we are using. Now we have to know like which subcarrier spacing we are using. So if we talk about FR1, so FR1 supports subcarrier spacing of 15, 30, and 60 kilohertz, while your FR2 supports 60, 120, and 240 kilohertz, right? Now this 240 kilohertz has been specifically, you can say this is reserved basically for the transmission of synchronization signals. And PBCH, physical broadcast channel, right? So if we talk about these, this is we are talking about subcarrier spacing, right? So lower subcarrier spacings like 50, 15, 30, 60, right? Let's talk about 15, 15 and 30, right? So this smaller subcarrier spacings have longer symbol durations, right? So these would be good for basically you can say larger cell ranges, right? And if we talk about 60, 120, right? So these would be having shorter symbol durations. Shorter symbol durations, which supports lower latencies. So if we talk about lower latency, right, artificial intelligence requires pretty much faster response. So lower latency required there in AR. So one more aspect, right? So if you talk about the voice, how voice was supported in LT. So in LT that was known as VoLTE, right? and in NR that is known as PONR. Okay. So both 4G and 5G have been designed to support the packet switching services. तो 4G में सपोर्ट करते थे स्पीच सर्विसेज कैसे, वॉइस ओवर एलटी के जरिए, राइट, जहां जबकि 5G में हम कैसे स्पीच सर्विस सपोर्ट करते हैं, वॉइस ओवर एनआर, दैट इज वीओएनआर। 4G नेटवर्क्स में हम लोग सपोर्ट करते थे एसआरवीसीसी, राइट। So to allow the inter-system handovers towards the circuit switch technology, like 2G and 3G, right? So release, if we talk about specifically release 15, so release 15 does not support SRVCC for 5G, right? But packet switched inter-system handovers from 4G to 5G are possible. What is possible? Packet system handover, right? Packet system handover from 5G to 4G are possible. Okay. And SRVCC from 5G to 3G is specified within the release 16 of 3GP version. I'm going to write this thing here. SRVCC from 5G to 3G is supported within release 16 of 3GBP specifications, right? So this was some introduction to the fundamentals of NRs. So I'm gonna stop here for this session. We're gonna meet in the next session. And if you have doubt, please post it that in the comment section below.